the total life under different loading is called cumulative life. Cumulative life. For example, let's say first stress is acting on the shaft or member sigma 1. Let's say its value is completely reverse, 250 megapascal. Under this stress, it is completing small n1 number of cycle. इस स्ट्रेस को अप्लाई करके it is completing small n1 number of cycles only. But if continuously you apply this stress only, then it could complete capital N1 number of cycles. Capital N1 number of cycles. If you apply only this stress continuously up to the failure, then it will complete the capital N1 number of cycle. N1 cycle complete कर सकता था, लेकिन चलाया गया only for small N1 number of cycle. Let's say it can go up to 100 cycle, only let's say 40 cycle you are running with this stress. Then stress value is change. Sigma 2. Let's say 200 megapascal. Okay. Under this stress, N2 cycles are completed. If you apply only this stress from start to last, it can complete N2 cycle, but you are running only for small N2 cycles. Okay. Now, similarly, sigma 3, let's say it is 300 megapascal. Under this stress, only N3 cycles are completed, but it could complete alone N3 number of cycle capital. Got the point or not? Like this. Okay, so here the stress value is continuously changing. Total life of the member will be given by sum of all these small n1, small n2 like this. So total life will be capital N. Total life will be capital N. Now, this N1 is only a part of capital N1. Yes or no? So, small n1 by capital N1 will be a fraction. होगा fraction. Second fraction will be this n2 by n2. Yes or no? Similarly, this will be also a fraction like this. When you will add all these fractions, then the total value will be 1. Total value will be 1. So, this will be your equation 1. And it is called your Miner's equation. This is called what? Miner's equation. Miner's equation. Okay. Now, with respect to time, let's say when you are applying the sigma 1 stress, it is applied for 85% of the total life. 85% of total life. Okay. So here this one becomes some fraction of total life. So it will be considered as alpha 1. Alpha 1. So alpha 1 will become 0.85 fraction. And this fraction will be given by small n1 divided by total life. Total life is n. Total life is n. Got the point or not? So here small n1 by n will become your alpha 1. So small n1 you can write equal to alpha 1 into capital N. Similarly, let's say under the stress sigma 2, 5% of total life are covered, then alpha 2 will become 5%, 0.05. So n2 by total n will become alpha 2. So here n2 will become alpha 2 into n. And third, 10% of life, 10% of total life, sigma 3 stress is applied. Then this will be your 0.1, 10% ka 0.1. So it will be your n3 by n. This will become your alpha 3 and n3 will become your alpha 3 into capital N. 85, 90, 100. Total only 3 loadings are applied. Let's say only 3 loadings are applied. Got the point or not? So here in this equation, n1 is equal to alpha 1 into n, n2 is equal to alpha 2 into capital N, n3 is equal to this. So put these values, so you will get here alpha 1 into n divided by n1 plus alpha 2 into n divided by n2 plus alpha 3 into n divided by n3, like this. So this will be equal to 1. Okay, equals to 1. Here the capital N you can take right side. So alpha 1 by n1 plus alpha 2 by n2, like this. If there are 3 or 4, any number of loading can be there. This will become the equation. So this will be your equation number 2, and it is also called Miner's equation. It is also called Miner's equation. Okay. So there are two Miner's equation. One in terms of small n and individual n1, n2, n3. Second is in terms of alpha and the capital N. Everyone clear up to this? Write down done here. All done? Okay, good. So now let's take a problem on it. Let's take a problem on it. Write down how to solve this type of problem of cumulative life. First, a steel component is subjected to a steel component is subjected to different completely reverse loadings different, completely reverse loadings as sigma 1 equals to plus minus 350 megapascal for 85% of time. 85% of time. Sigma 2 plus minus 400 megapascal for 12% of time. Sigma 3 plus minus 500 megapascal for 3% of time. 3% of time. If sigma ut is equals to 660 megapascal and corrected endurance strength of the component is 280 megapascal, then find the total life of component. Total life of component in cycles. In cycles. Okay, so total number of cycles, capital N, we have to find. Clear? So now check how to solve this type of problem. First of all, sigma ut is given to us 660. So sigma E dash will be sigma U divided by 2, 330 megapascal. At this stress, 10 to the power 6 cycles will be completed. Now, they are saying the corrected endurance strength of the component is 280. So this will be considered as your sigma E. Sorry, for this not 10 to power 6. This is not corrected. This is for specimen. Corrected is this. Corrected means after taking the consideration of all factors. So 280 is directly given to you. So at 280, 10 to the power 6 cycle will be completed. But sigma 1 given for 85% of time, sigma 2 given for 12%, 3% like this. So here what you will do, you will find the value of alpha 1, alpha 2, alpha 3 like this. Alpha 1 will become 85 means 0.85. Alpha 2 will become 12% 0.12 and alpha 3 will become 3% 0.03. That's it. So here alpha are known. Now you know the Wiener's equation in terms of alpha and the n1, n2 and capital N. Yes or no? So if somehow you can find the value of n1, n2 and n3, then you can find the value of n. Yes or no? So alpha are known. You have to find this, this and this. Then you can get the value of n. Clear? How to find the capital N1? Capital N1 will be, for this stress, 10 to the power 6 cycle. So for this stress, how many cycles it will complete? Those will be the total number of cycle capital N1. होगा कि नहीं होगा? So that we can find by what? SN curve. Yes or no? So that we can find by SN curve. But SN curve we will not solve for 3 times. We will find a equation. We will find a equation between the number of cycle and applied stress. Look here how. This will be the curve. This will be the curve. This is for endurance strength. This is for any general sigma f. So for any general sigma f, we will find the relation. For any general sigma f, we will find the relation. Here it will be 6, here it will be log 10 n, and here it is 3, 0. Point A, D, E, C, B. Now find the value at point A. Point A value will be log 10, 0.9 sigma u. What is the value of sigma u? 660. So check this value, it will be 2.7738. Then D value. D value will be your log 10 sigma f, any general. Then C value, log 10 sigma E, 280. So this is equal to 2.4472. Got the point? Now again, compare the triangle ADE and triangle ACB. Again, AD divided by AC, DE divided by CB. AD will be equal to A value minus D value. A value minus C value. DE will be log 10 n minus 3 divided by 6 minus 3. Okay. So here you will get a general relation between the number of cycles and the fluctuating stress. So when you will solve, you will get this equation. You will get this equation. Okay. Equation number 6. So this you are getting as a general equation. Now put here sigma 1, you will get the value of n1. Put here sigma 2, you will get the value of n2. Put here sigma 3, you will get the value of n3. Yes or no? तो सारी वैल्यू मालूम कर सकते हैं. $350 पुट करो, you will get n equal to n1 equal to 128,798. This will be the value. For sigma f equal to sigma 2, 400, n will be n2, 37770, and for sigma f sigma 3, 500, then n will be n3, 4865 only. Okay. So now your n1, n2, n3 are known. Alpha 1, alpha 2, 3 are also known. Can you find the value of n? So from equation 5, put the value of alpha 0.85 divided by 128798 plus alpha 2 0.12 divided by 37770, then 0.03 divided by 4865, 1 by n. So the total number of cycles 62723 cycles. This will be your answer. Is this clear? सबको क्लियर हुआ तो जय हिंद लिखो।